is the first demo rough draft of a concept called nobook for retrofitting legacy knowledge into modern collaborative systems. So what we want to do is we want to move all of the years of course content and lectures from Word documents and PowerPoint files and PDFs and get them into formats like Markdown or Jupyter that are more collaborative and more modern and actually teach modern literacies. Because one of the goals that we have is to integrate open science into the next generation workforce. And open science requires new literacies, and one of them is Markdown is a modern literacy. So teaching students how to contribute to Markdown, write Markdown, order emphasis and hierarchy to their content, it's important. And we want to figure out how we can integrate open source and science literacy directly into education as a hands-on vocational sort of training. The goal of these resources is to be community collaborations, community resources, shared resources, kind of like wikis for contributing to course content, because the students are our best future contributors. The ones who have taken the course, the ones who understand the content, it's very fresh for them. And maybe they can help us make better content and adapt our legacy material quicker using collaborative systems. And the way that we collaborate best is we choose open standards and protocols and deliver internationalized and accessible experiences. With all these constraints, it offers a very good basis for a lot of people to participate in. And we have to recognize that education's move from finding information to filtering information. It's a too muchness problem. So we're going to present this concept of learning to work with textbooks as data and see what that could mean to future students. So I doubt many folks have thought about this, but we can look at a docx file as a collection of paragraphs. We can actually look at a document file as data. And that's what this is showing here. This is a pandas data frame with the 3,200 or so paragraphs from a formal docx file that is a textbook for computational thermodynamics. And what we're going to do is we're going to treat this data and engineer some features so that we come out with notebooks, because notebooks are a very general standard. So when we have this data frame, we can go and now start parsing some of this information. For example, one of the things that we want to do is we want to facet our data frame into notebooks. So in this situation here, we've gone and taken our original features, and now we can go and figure out where the title of each of our headings. We can go and think about each chapter as a package. We can go and think about each section as a document, and we can eventually target a file system on disk. And this is an example of a docx faceted into potentially a bunch of notebooks. And when these things wind up on GitHub, they're collaborative and well formatted, and the equations actually show. So now we have our docx objects, and one of the things that we want to do is we want to go and turn those into Markdown, because that's sort of the lingua franca that we think that a lot of our students are going to be communicating in. So this example here shows a mapping of a packaged document and cell ID to a collection of Word paragraphs, and all of that translated into Markdown. And now Markdown is a native cell type in the notebook. So we can go and expand those Markdown objects into notebooks. And with all of this, we can start saying, hey, we've got all this data. We've got information about our notebooks, our documents. What else can we imagine testing? Can we do spell checking, internationalization, accessibility, integration testing? We've demonstrated some of that within this exact program here. So now that we've cooked all of these things together, let's go and write the notebooks. So these notebooks actually show up on disk, and then we're going to go look at our file system. If we're going to have to traverse quite a few folders here. This is all because it's programmatically generated, and we're going to hide a lot of this complexity. But let's say we start off with the law of thermodynamics. Here are generated notebooks. One of them would be naturally the first and second law of thermodynamics. So this is a markdown cell generated from the data frame. It hasn't been split up yet. But it's not a bad start. So from here, we can imagine people coming and treating this and adding links and more different kinds of media and different representations of this knowledge that might speak to more potential students. So if we look a little bit further, we've got these glimpses of computational notebooks and literate programs. So this is a reworked version of the first and second law of thermodynamics notebook that we just looked at. And we start out by defining our type system. So we define all of those variables explicitly as computational objects. That's Python that just ran. And this is the original paragraph here, but this is an alternative syntax that's still a work in progress, but it allows us to actually directly put these equations and symbols into Markdown and have these objects appear as code. So these are SymPy objects that are representing the equalities in an isolated system. These are each of the variables showing up here. So we get nice formatting from IPython and Markdown. And one other cell here, this one takes a look at internal energy. So now we can go and explicitly define our types, explicitly define our variables. And now our first law is written as a computational algebra variable. It's represented as an equation that we in the original form that we had, but it is reusable as code and something that our students will be having to do in their future careers, which is turn language into code. So the goal of these open textbooks is to teach students to turn language and symbols into code and models. We stop there, and that is the ultimate vision for the open textbook.